Let's start then. Given that recently we had some more people asking how to get the engine running, I thought I would take like a couple of minutes to just show how to start with a fresh install. It's not going to take more than a minute or two, as most of you already know. So let's just do this. We are going to clone the repo on GitHub. Oops. That takes a few seconds. Once the repo has been cloned, we just run setup. We only have to run setup once after the first clone. Every time you're going to change branch, checkout, pull, or any Git action, setup will be run for you automatically. We just need to do it the first time so it can hook itself to the Git system. And what setup does is sync the external dependencies and also prepare the build project for all the platforms and all the IDEs we support, and set the aux environment variables. Running setup is going to download dependencies from internet. Done. Everything is extracted, and right now it's just going to. So I'm not sure why on my Windows it takes like a few seconds to set the aux environment variable. On my other machine it's like instant, but in any case it's only like 20 seconds, so it's not too bad. And if we look at the environment variable, we see that aux is not set. It's because we need to start a new command prompt for the new environment variable to be taken into account. And same thing, if we had like Visual Studio open already, we have to close it and start it again. Otherwise, it won't know about this environment variable. So that's exactly what we're going to do. I'm going to close this prompt here, and I'm going to start a new one. There we go. Live. And now if we check the environment variable, we see that it's been set. That has been set to aux code. So we're going to go to aux code, build, Windows. I'm going to compile it the Visual Studio 2022. The solution is called aux.solution. And we're going to build all three uh, configurations. This is my face. Good. So building the debug one. On my machine, it takes about 3 seconds to build the engine and the background. Profile, same thing, building, done, and the release version. And we're done. We build all three configuration of aux, and we're set up and ready to go. You don't need to click a couple of minutes. As you can see, the demo is working. We can play with it. My virtual screen apparently is set up to 120 Hz, and I have no control over this. So all these demo are running at 120 FPS. Let's get started with our agenda today. So the first one in line is going to check the profiler. Actually, you know what? I should probably just go back to Visual Studio. We're going to use, there we go. We're going to use the playground to showcase the profiler. So we're going to go in the profile configuration. Both the debug and the profile configuration of the profiler activated. In release, all the profile marker have been removed. So if you try to display the profiler in release, it's not going to appear. It's going to be completely empty. And by default, when we run the profile playground, you can see that the profiler is displayed here. I'm going to zoom so that you can read after. Let's go to this kind of resolution. I'm going to zoom so we can see what's written. But by default, the profiler is not displayed unless you ask it for it. And it's managed through one configuration variable, which is in render, and it's called show profiler. And if we set it to false or 0, it's not displayed. If we set it to 1 or 2, we have the profiler. So let me see if I can do it here. Oops. Is this I have no clue if it's working or not. Hopefully you can see the zoom and it's not too annoying. The profiler by default is going to give you all the metrics for the markers that have been set in the engine. And you can also set the markers in your own game if you want them to be displayed in this embedded profiler. And there's a few controls. So if you press F5, it's going to pause the profiler. And if you press F8, you have, so let me, you have a graph of the profiler at the bottom. The graph is live, and you can see that if I spawn a bunch of physics objects, we see the graph change a bit. If we press F5, we pause the profiler, and we can navigate the last 300 frames and see what was going on here. So let's just pick like this frame, for example. I'm going to zoom again. So the top left, we can see the main thread right now, and we can see how long the frame took. We are at 60 Hertz, and because I started it on my screen, that was 60, I guess. And we can see what we're using in the frame. Let me actually, sorry, I can't see. Show cursor one. No, much easier. So here, this part here shows how much of the frame we're using. The gray bar represents the total of the frame. So all this is 16.7 milliseconds, and we are using this at the moment. The white marker tells you that at the bottom of the screen, this is the line, it's the first depth of marker that we're showing. So here, for example, it's a render all, and you can see that under render all is going to have other function call or other markers. We have the render viewport. The render viewport itself, under it has the render object. Inside the render object, we have render object 2D and text, and 2 would be this one. If we look at the bottom of the screen, we can see that the colors we see are just the first line. So that if we were displaying all the line at once, it would not be visible at all. So what we can do is use the up and down to navigate between the different depths. So at depth 1, depth 2, depth 3, depth 4, if I go, for example, at depth 2, you can see at the bottom, it changed the colors, and we can see exactly how much. Yes?
What you're showing on Twitch and on here is completely different. On Twitch, you have the full screen, and we can see
Oh,
everything you're doing on the left-hand side of your profiler. But on Discord, we only see the right-hand side where all the white text is. So we're not really seeing
I
what you're
guess.
doing there.
Sorry, so the magnifier is not working. Is it better if I do that now? Can you see the entire screen?
Yes, yes. Now we can see everything. Sorry about that.
Okay. No, it's me. I was trying to use the Windows magnifier. I guess that's no go. So sorry, the text is going to be a bit small. I have no way for to zoom the text at the moment, so I will read it for you. Yeah, sorry about this. Going back to the profiler, at the top left, so we see a visual representation of the markers and how much time they are taking. And we have the detail under it. So we have the name of the markers and the depth. So the depth that displayed, so the white square we see at the top left, it match with a little asterisk here. So here, for example, we're displaying the one at level 2, and we can see it's the one uh, you have my mouse here. Render viewport, render profiler, physics apply simulation result. This is at the level 2, level 3, level 4. We can navigate up and down. We can navigate between threads as well with page up and page down. So this is the main thread. We have a runner thread that does nothing at the moment. It was used at the beginning to decompress the bitmap. This one is to process requests. There's a very low activity. It's the hot loading support that's been active. And the last one is the sound system, the streaming audio. There's nothing going on here either. And at the moment, we only have 4 threads. But you can create your own thread. Arcs is only using those 4 threads, but you can spin new threads through Arcs, and they will show in the profiler with page up and page down. So the marker on the left, the ones that are colored like this, means they are only called from one place in the code. So they have a unique parent. That's why we can place them in the frame. And those are the colored ones. The one on the right, the white ones here, They are white because they are called from multiple parents. So instead of putting them like a regular profiler, like everywhere they appear and having them completely invisible, because some of them have been called like hundreds of times. Like for example, the bank allocation we can see has been called 793 times in that particular frame, or the config value was called 1000 times in this frame. Uh, it would be like a huge mess. So instead, I just aggregate everything and I show you like a bar of the total time spent in this call. So even if we had 1020 events sent, that amounts for about this much in the total of the frames, which is 0.31 milliseconds. Speaking of which, all the grayed out markers are haven't been called this frame, but they have been called in past frames. So actually, if we navigate, you can see on the left that some are moving. It's because in this frame, for example, we were freeing, I guess, particles, 4 of them, and the frame after we were not freeing anything, so it went back at the bottom, grayed out. The way we read the profiler is we have first the name of the marker. Usually it's a function, but you can actually like profile a block in the function. It's really up to you. And the first number is how much time it took in the current frame. The second number is the highest time it took over the last second when that frame happened. So here, for example, if we look at the render all, which is the first one here, we see it took 0.46 milliseconds this frame, but it has a high of 0.86 milliseconds in the 1 second window gap before that frame. So it gives you an idea. And the last value is how many times it was called within the frame. So we only call render all a single time in the frame, but we apparently render two viewports because there are two calls for render viewport. And we do have two viewports in this demo. We have the one that renders to texture and then the one that composes the texture to the screen. But we see we also were rendering 240 objects, out of which 128 were 2D and 111 were text objects. Lastly, the last thing we see at the bottom right is a green thing. It's the memory. The memory, though, doesn't have a history like the profiler. So all the markers that we can navigate, the memory doesn't do that. It only displays the current state. So as we see, we can see that there are some numbers moving. I will explain what it is. So basically, the memory it's broken down into multiple parts. We have the main memory, the audio one, the config, the debug, physics system, a temporary one that's not used right now, that's why it's grayed out, and so on and so forth. The first number tells you how many live instances allocated in that memory pool there are. So in the main memory, we have 409 allocations live at the moment. The number next to it is the all-time high. So how many max allocation we had. So for example, we see at some point we had 10 allocation in the video, and right now we only have 9. The second bracket is how much memory it takes. So right now we have 3.89 megabytes allocated in main memory, and the max was also 3.89. If we look at the video one, right now we see we have 8.16 megabytes allocated, and the maximum was 8.18 megabytes. The last number are how many transactions have happened since your game has started. So we see that most numbers do not move, mean that orcs is running at the moment, but is not making any memory allocation whatsoever. Since the beginning of the game, it made 411 memory allocation in the main pool of the memory. They are not actual pools, they are more like a section. In the main section of the memory, only 10 allocation for the audio, 21 for config, and so on and so forth. Here we can see that the text is just having a lot of allocation. Right now we have 74,000 allocation, even though the number of live allocation and the memory isn't moving. It's because right now there is a little, in this test, I have a label that's hidden at the top right that I can make appear in the debug version. Actually, let me show you in the debug. Up. So debug. If we ask for the profiler and show profiler, oops, what did I do? Profiler. There we go. Let's make it a bit bigger. No, not that big. Like this. And if we look at the memory, you can see there's a label at the top right sometimes that appears. If we activate the debug for the physics, so set physics, show debug 1, we can see all the shape. And if I press space, I actually shoot a recast, and the top right displays the name of the object that is intersected by my recast. So it's really something I put in the playground. But this label is updated every single frame. So every single frame I update its text content, and that's the counter you can see here. It's doing one allocation per frame. If I were to remove, so bounce, let me find it. Bounce, I9, that's the one I want. Sorry, I have, there you go. Oh, it's not in bounce, it's bounce out. If I look for the relabel, you can see this object here is having a track that runs every time, and it calls object set text. And this one is doing a memory allocation. It's actually duplicating the string. Let's say that we are going to remove that label by just changing its name. And now if I run aux, let's put it back in profile so that we have the profile up. We can see that there are no more memory allocation happening for text. So it was just this track doing it. And you can see that even if I run aux, like I have a bunch of physics objects, have some shader, a trail, you can see that aux does not do a lot of memory allocation or at all. It's only when there were text, like when I was spawning text, for example, we saw some activity in the text. Everything else is extremely stable. That's also one reason aux is very good on performance side, that there's virtually no memory allocation unless you really need to grow your pool or you're making allocation yourself. So that's about it for the profiler. Is there any questions regarding the profiler? And obviously, you can use any external profiler you want. This is the one that's embedded with aux. It's just convenient for like spotting things really quickly. Well, actually, as long as we're here, let me show you something really quick. So we've seen how many objects are rendered by looking at the render objects. So we see that if I bring a bunch of balls, we are rendering about 200 of them right now. That's per the profiler. And if we look at the right side, so better with the mouse, if we look at the right side here, we see there's a function called org_display_draw_arrays, is how many batch were submitted to the render pipeline. And even though we were rendering about 140 objects, we were only displaying 8 different batches at this time. Aux will do auto batching as long as you're reusing the same texture, the same shaders and blending properties. It will try to batch all those into the same call. So that's why even though we had 140 objects, we only have 8 draw calls issued by aux at the moment. Anything else interesting here? Yes, I guess you can also see if you have like a very config heavy, if you're like reading a lot of config values in your game, you can look for org config get value and see how much it impacts. Right now, there was only 14 in this frame and virtually 0.00 milliseconds. So it's either in microsecond or nanosecond on my machine. You can also see how many events are sent, and like if you are very heavy on FXs, it's going to show in the FX pointer update. So this will give you like a broad idea where you have like performance bottlenecks, if you have any, obviously. So yeah, this time I'm really done with the profile. We're going to do a bit more debug. Oh, is there a question?
I was just going to ask if there's any recommendations you would have either for using it in like a using the profiler, the markers for the profiler in a project that uses orcs, or if that's something you would recommend against and kind of leave this only to the engine itself.
Oh, no. You are welcome and encouraged to use them for your own needs as well. But I would not bother unless I see like performance issues. So for example, if you run orcs and you see there's a lot of time that is not accounted, like for example, when you look at the profiler right now, that's, oops, sorry, I have a virtual screen. It's really hard to know where I am at the moment. I guess I'm here. No, wrong one. Okay, let's try this again. Profile. Okay, and I am here. Okay. Hey, what's happening here? What did I do? Ah, it was paused on the terminal. If you do a section on terminal, it blocks the terminal and blocks the execution of, I'm not sure why. Anyway, so if you look here, you can see the color bars at the top. Let me go into, no, not full screen, like a larger resolution. And here you can see that all the bars are like very tight together. I mean that there is no time that's not accounted by the markers that ship with orcs. But sometimes you might see like big gaps, or you might see like, for example, in the event send, there's a lot of time because it can be in your code, and orcs only knows that it's sending event. So there you can refine by adding your own markers. And to add a marker, it's actually very simple. Let me show how you do it. There is a syntax. So I'm just putting that somewhere. It's orcs profile, orc profiler push marker, and you give it a name. And when you're done with the section you want to profile, it has, probably guessed it, there's orcs profiler orc marker. And in between those two, the section will be timed, and it will be put in either the left side if there's only one unique parent, or the right side if there's multiple parents in the graph. And yes, I do recommend for you to use them in your game. It just don't put them everywhere in your game, otherwise you might end up with too many markers, and it's not going to be very relevant information. Put it when you need it. So like if you see that you have a bottleneck or the frame rate is not what you expect or something like this, then you can add markers if the one provided with orcs are not good enough. But yes, you're welcome to use them, and as long as you're using the debug or the profile version, the markers will be there. In release, all the markers have been compiled out, so you won't have any. Actually, I can show you what happens if we start the release version. There we go. And if we try to activate the profiler, set the show profiler, you see that it is empty. There is not a single marker. Is there any other question on the profiler? No? Okay. Next one, we're going to look into another very useful function for debugging, especially when you have objects that do not appear on the screen. Like you have some objects and for some reason they are not rendered or they are not where you thought they would be. And this function, it's a command. In the console, it's called LogParents. So let's give it a try. If we look at the config here, we can see that we have an object called particle source. Particle source has a spawner called spawner, not very original. And the spawner is spawning an object called particle. And those particles, are defined here. Those particles, when I run, let me run release actually this time. Those are the little cross that are spawned under my glowing purple ball, which is under my mouse. And those particles have, like any object, they have a position, scale, and a rotation. So we're just going to find one and display its parents. So we're going to object find next particle, and this object we're going to ask to log its parents. There we go. And we're going to look at this version here. We can see that particle actually has no parents. When they're spawned in in the world with no parents. We can see that this particle, that was its grid, that was its position, local rotation, and local scale. And you can see that because there's no parents influencing it, the world position, rotation, and scale are exactly the same. And then the inner flag are set to none, and we will come back to this later. Now let's say that I have a slightly different setup. If I do this, it's going to, there we go, to pause orcs otherwise. If I were to spawn the particle, so let's go back to spawn now. If we were to say use self as parent for our spawner, the spawner will introduce itself as the parent of the particle, and any parent of the spawner will also affect the particle. So let's start again. You can see that the obvious thing is that now the particles are stuck with my spawner because their local space is the spawner space. So if the spawner is modified, so are the particles, and they become attached to it. So if we do the same test here, we can see that now, I don't know if it's big enough to read. I'm not sure if I can. Yes, I can zoom. Okay. We can see that the particle has a parent, which is a spawner. The spawner has a parent, which is a particle source. And the particle source actually has a parent, which is a ball spawner. And here with the grid, we can get more information. The last two digits of the grid is actually the structure ID. So here we can see that they are different. Here we have 0xf, here we have 0x8, so they are different. The way we can know what it is by simply going to look at, they include the structure. So in the object, we have org structure.h, and those are all the structures that are used inside orgs at the moment. And there's an enum called structure ID. And if we look at their number, so 0, 1, 2, 3, 4, 5, 6, 7, 8, the one that has a grid that finishes with 8 is a spawner. And F is 15, 9, 10, 11, 12, 13, 14, 15. So the one that finishes with an F is an object. So here we have object, which is a child of a spawner, which is a child of an object, which is a child of a spawner. And this spawner is actually moved in the code of the playground, and it just matches the position of my mouse. So we can see that here, the position of the local position of the ball spawner and the local position of the ball source are not always matching. So like here, the ball spawner have no parents. Because it has no parents, its local position and world position are the same. But the particle source, the spawner is a ball spawner. Even though on X and Y it has 0, and on Z it has minus 0.2, it's local to the ball spawner, which means that the world one, it's the position of the parent plus the position of the child, and the rotation can also be applied. Here there's no rotation, so we don't have to worry about it. So the world position of the ball spawner combined with the local position of the particle source give us the global position of our particle source. And you can see here the only component we're changing is the Z. We are adding minus 0.2, so we're going to minus 0.7. And this way, when you see the world position of your particle, you can see what parent has actually affected it and why it is in its current position. So let's see, for example, if our spawner, we were changing our spawner right now. And let's say that our spawner, we're going to digital rotation 90. And you can see that my particles now are going sideways. And if we were to run the exact same, same thing here, we can see that there's so it's in radians. So radian, half pi is 90 degrees centigrade. And the spawner is rotating 90 degrees, which means that the rotation of the particle is affected, but also the position of the rotation, the position of the particle has been rotated 90 degrees. So that's why here we have these values because of the rotation of the spawner. If, like, for example, we were saying that the spawner, was 180 degrees instead, now they're flying upward, and that's due to this. Oh, by the way, right now the the hot reload is active. That's why changing the values in config affect the object at runtime. But if you don't set the hot reload to be active, changing the value only will affect the next run of the game. Another thing that we've seen is the flag. So let's remove the rotation. Okay, back as they were. Another thing we've seen is the ignore from parent. So let's say we go to the particle and we add something like ignore from parent. And I say I want to ignore from parent the position component, and the Z1. So visually it looks the same, but if we were to run this and looking at the result, we can see that now, okay, that's this one here, yes. You can see that the position used to be minus 0.7 because it was taking the hierarchies transformation from all the parents. But now, because we asked to ignore the position component of its position and only the Z component, we can see that its Z remain at 0, which is the same as the local one. Let's ignore another axis, like for example, let's ignore the X one as well. Oops. And now you can see that it follows my particle vertically, my glowing orb vertically, but not horizontally. It's because we're ignoring X. So if we were to do the same thing and log the particle, you can see that the position, now the X value is not affected by the parent anymore, it's affected by the scale. So basically, you would have to do the computation to see why the position is there. But you can see that we are not in minus 38 as we were before. We are at 70.75 on X, and this is the same thing. However, the Y is still following my glowing arm. So that's why the object log parents is very useful to try to understand what's happening to an object, especially if you don't see it, to see what parents is affecting my object. So object log parents, very useful debug command. Is there any question on this one? All good. Let's go to a different project. We're going to go to large world. Most of you are probably familiar with large world. And okay, there we go. So there it is. If I were to start it, it's going to be on the wrong screen. You don't see it, I assume. Let me change this. So we're going to go here. Come on, everything. I guess there we go. So if we go to its data and config and we look at its config, of course it opened it in the wrong one. Sorry about that. Let me find my bearing again. Let's open it. There. If we were to get it displayed, and we're going to say, I want you to go on the second monitor. And running it. Okay. Hopefully this time you see it on the right monitor. You should be seeing like a space scene. I can move around and zoom.
We do.
Okay, excellent. So here, let me actually run the profiling so that we have the profiler as well. And that will be this one. Okay. So let's put a lot of objects. Here, when I dezoom, we are rendering about 2,500 objects, and it takes about like this here in the frame, so it's 0.65 milliseconds. And we can see that it takes 0.22 milliseconds to render 2,500 to the object, and like almost nothing for 3 text. And this part here, the thing that you don't see is that in the render object, that's where also we do sorting. Because we are displaying 2D objects and not 3D ones, and they all have transparency, we need to sort them ahead of time. And that sorting can be expensive when we have a lot of objects in the same space. So let's see how it works. If we look at the config, there's a camera, and my camera has a group list. So basically, each group is rendered separately, as most of you know. In fact, we're going to render a group called black hole, then nebula, then cluster, star, planet, and moon, and UI. So for example, if I were stopping a nebula, we would see only black holes and nebula on the screen, and nothing else. Each path is rendered separately, meaning that inside each group, we're going to sort the objects in it to render them so that their Z component is taken into consideration to sort them. But objects in two separate groups are not going to be sorted one compared to the other. However, sorting is expensive. So what we did here, because I don't care about sorting inside a group in this particular case, for each group, you name the group and you ask for row, meaning that you just want the row content and display it without sorting the object. So they are just going to be displayed in their memory order. We're just going to go over each list, each group, and render them in each path. If I were to remove this, so let's, it was 0.65, I believe, timing for about 2500, yeah, 0.60, yeah, 0.6, 0.7 milliseconds. And that's without sorting. Now, if I were here and like remove all this, by default, Orcs is going to sort all those objects inside it. And if I look at this one here, and let's go back to the same setting. Now we are about the same number. No, okay, so the render viewport, it's in the render viewport, not the render object, sorry. So the sorting appeared in the viewport. So right now we are at 3 milliseconds something for my viewport. And if I deactivate the sorting, start it again, go to high settings. Now we can see my viewport is only taking 1.9 milliseconds. So we add a 1.5 millisecond cut down just by removing the sorting. And if you have things like 10,000 of objects or like 50,000 of objects, the sorting is what is going to kill your frame rate. It's a very expensive operation, and if you do not need it, you should set your group to row. If you do not have a group defined for objects, like if you have no group list, by default, camera is using an implicit group that's called default. So it's the same as this. And you can ask for defaults to also do not sorted. Default row would be saying that we don't sort anything. But here, for example, I would have to put all my objects. Actually, you know what? Let's do a quick test here. All the objects here have a group. So let's remove all the groups. And let's render everything in the same one single pass. So if we render everything here, and we go in high settings, and with the zoom, we see that we are still rendering about 1.15 milliseconds for the viewport. And if I were to reactivate the sorting, and that's probably what it's going to fix us, I think, hopefully. Okay. Now, the sorting of all the objects in one single group, we are at 6.6 milliseconds. So it's like 5 milliseconds more just for the sorting of this object. And if you look at the, oh, you don't see my, okay. So, if you look at this top here, this part here that's not with no marker, it's actually the sorting of this object. Sorting 2,500 objects is very expensive. It's a square M operation. So you want to avoid having large group of objects to sort. It's better to cut them in multiple small groups or just to ask them to be unsorted if you don't care about sorting. If you care about sorting, try to isolate them in smaller groups. Of course, if they are scattered over the world and you're only rendering a small portion of your world, we're only going to sort the ones that are inside the camera first. So you don't have to worry about this. But let's say you have a lot of objects in one places that are rendered at once. It's better to not sort. Like you see now, okay, sorry. you see that the sorting happens in this here, which is like tiny compared to the 5 milliseconds we were seeing earlier. That's about group sorting and cameras. Is there any question in this one? I take that as a no. So let's move on. Remove my mess here. Okay. And we can ignore about that. Oh, large world is an interesting one to show the profiler. I didn't think of this. But because we are storing, like we can bring millions of objects by just navigating the world, we generate them on the fly. We can see the evolution of the memory, and that the memory is very stable, and that the frame rates remain at like a few milliseconds, like you've seen, no matter how many objects there are in memory. I've been up to, I think, I got the patience to go up to 4 million before I was bored and I stopped. So yeah, it might be a video for another time. Oh, we were having some fun with cursors before, so let's go back to this one here. Oh, and for some reason, yeah, there we go. Come back here. So you saw me, you saw me show the cursor, and if you remember, okay, here, there we go. If you remember, we can also change the cursor. So, oh right, I don't have any image here. See a ball, for example, I guess. So if I want to change the hardware cursor, because this is a hardware cursor, see it goes outside, I can change it to like images that Ox is going to load for it. So the ball images is one that can be found by the resources, and it replaces the hardware cursor with this. So it's something that was already there. Let's try with wall. Yeah, same thing. But in the top left by default, you can provide like a pivot. So I don't remember the. It's probably something like. Let's try to aim for the middle. It's probably something for the middle. Yeah. So now we're in the middle of the image by adding a pivot to the cursor. But we also can use the native OS cursor. And so before we add like the I-beam, which is the text one, we add the hand one, we add the arrow one, which is the default one, and we add like a couple of others. But there are new cursors that have been added with the new recent version of GLFW. Sorry, I need to drink. And those are resize east-west for the horizontal one, north-south for the vertical one, northeast, northwest, southeast for this diagonal one, northeast, southwest for the other diagonal one. We also have resize all for the four ways, and finally we have not allowed for this sign. And if you don't pass any parameters, it just restores the default one. So those are now part of Fox. One something interesting also that has changed with the newest version of GLFW, something I patched from a pull request that they have not merged, is the fact that now, even if you move the windows, the simulation still runs. Whereas usually in the Windows, on the main thread, if you start moving or resizing, it blocks the event pump. And if you are processing your world on the main thread, well, everything is blocked. With this change now on Windows, you can actually have the world continue to be updated even when you are resizing the window or moving it around. On Mac and Linux, it was already the case. It was only on Windows. So that's a nice thing that has changed recently. Okay. Any question on this? Otherwise, let's move to the next topic. Let's create a new application. So creating a new project, you are all familiar with the init function. There we go. And we're going to create a new project. We're going to put it in live and call it live 11. And we are going to ask for the mod extension. That's the only one we care about today. because the the second one we care about is the bundle one, but the bundle is on by default. So I guess I can select it. Mod and bundle. The project has been created. So let's now go to it and go to build, Windows, Visual Studio, and it's called Live 11. So let's close Ox. There we go. And we can build it. We're going to make the usual changes that we always do in the config. So creation time, not Live 11. We're going to say no for decoration. Screen width, we're going to go for 1920. Screen height, we're going to go for 1080. We're going to ask it to go on the second term. And for the console, it's, I forgot the name of it. It's in render console font scale. Not sure I remember this one correctly. Yes, the console is scaled. Okay, you can hear the music already. So in this project, let's first remove the sound and the music. Actually, the sound we're going to get rid of it entirely. No, we'll use it later. Let's not worry about those and remove the effects we have on the object. And let's focus on the object. Here, no effects at the moment. So we have an object, which is this rotating logo. Actually, I'd rather not rotate. Let's remove its angular velocity. Okay, we have this logo that comes from a texture that's embedded in the engine. And let's say we want to make it appear like sliding from the side. There are two new FX, FX types that have been added recently. So let's call it appear FX. And appear, we're going to ask for a first slot of null. And a null is going to be of type size. So basically, we're going to play on the size of the texture. The end value is going to be, we're not going to touch the end value, we're changing the start value. We're going to fold it. So the texture is 920 times 1080. So we're going to fold it on the X, so minus 1920. And we want this transition to happen like over 2 seconds, for example. And if I don't put a curve, it's going to be linear by default. And let's see, and you can see there's a reveal over 2 seconds. The size goes from completely big collapse to its normal size, which is 0, 0. I mean, relatively 0, 0. So here at the start value, relatively, we remove 1920 from 1920, so we start at 0. And when it's done, we arrived at the full size. Here we're going to change the curve. Let's try something a bit different, like ease in, out, quad. And you can see that we can animate it a bit, maybe something a bit more drastic, like this one. There we go. So that's a nice effect. Actually, you know what? Let's loop it. And if I put the loop at the right place, it's even better. 2 or 1 is the same thing. And over 1 second. So, okay. So that's a nice effect playing on the size, but let's say that we want to have it slide instead. We're going to play on the second type of slot that we added recently. And this one is called origin, so basically the origin of the texture. Let's call it slide. And slide, we're just going to inherit almost everything from Unroll. So adding slide here. And what we're going to change is the type, of course. We're going to say that it's origin. And this time we're going to do the opposite. So instead of collapsing to 0, 0 at the beginning, we want the origin to go all the way from 0, 0, where it is originally, to 1920 on X. So we're going to say that our start value equals 1920. And we're not playing with the white, but we could like make it slide vertically if we wanted, or diagonally, by just adding a value here. Because we also keep the same curve and the same time, it will be in sync with the change of side. And what we obtain is a nice effect of sliding in. So because we played with both the texture size and texture region, we can do this kind of effect quite easily. So that's it for FXs. And any question on this? Let's move to the feature that put Orcs as a really modern engine. Is recently I had this report for Screen Tracker 3 and FastTracker 2 modules. For those that are old enough, you know that modules are music formats that were very popular back then on the Amiga and Atari days. So I think of the 90s, late 80s, early 90s. Aux was supporting regular module, so the original Amiga format with the previous module extension, and that's the music you heard actually. So let's put the music back. Music here. This is an extension, so Aux itself knows nothing about modules, but the extension is going to use an empty string by default and listen to the packet event to fill the packet with decoded modules. And here we're just going to play Stardust. Let's put the volume lower. And you can see that that's what we used to have, like the Stardust memories module playing. But now we can play like FastTracker. Actually, I probably should copy the files. Otherwise, we're not going to find anything. I have like a bunch of them here. We're going to copy them into live 11 data, and we're going to put them in music. So FastTracker 2, they are .xm files. So let's try intro. FastTracker 2 working just fine. And similarly, we also have the Screen Tracker 3, which is also like from the PCC a bit later. Let's try castle.s3m. And here we can hear the Screen Tracker file. So obviously, most of you are not going to create files in those formats. But if someone wants to go with something like very, very small memory footprint, those files are usually like a few dozen or a couple of 100 kilobytes max. Like for example, the Castle one is 200 kilobytes. The Stardust memory is 114 kilobytes, and those are like 3-4 minute long music. Of course, they have like a very old school vibe. They are modules, but I mean now you can play them with aux, and you can do any kind of transformation that you would have on a regular like MP3 or OGG playing with aux. Mean that you can do time stretching, you can pause them, play them, everything works. But it's an addition on top of aux. The engine itself knows nothing about the format. Actually, if we start the profile one, and if we look at first we have profiler set and show profiler one. If we look at the sound thread, we can see that there's a task from time to time, and F8, right? Oh, it doesn't. It's so small that it doesn't show. Yeah, okay. Otherwise, we would see the graph at the bottom. When the music is decoded, it's not every frame. Yeah, nothing else will. Okay, I was hoping to see a bit more activity, but apparently decoding a module is quite easy. What isn't is like a MP3. Well, it doesn't matter. Well, if you were playing like an MP3 or OGG format, you will see like more traffic on the sound thread, but apparently not so much for decoding modules. But yeah, the ones that are old enough probably will recognize this one as well. Anyway, moving on to the next topic. Oh, unless, do you have any questions regarding modules? And this is the
I haven't
music.
seen any questions yet, but we are
Okay.
running up on an hour here soon.
We are almost done, actually. We have 3
Awesome.
more topics, yeah, and 2 ones are very short. So the next one is actually a recent addition too, is that aux can generate noise or waves for you instead of just playing music. So let's reuse our sound. Let's remove the music. We're not going to use this anymore. So here we have a sound that's just a regular hog. You can hear it when you start. But instead of having a sound, if we wanted to have like a stream, we call it music. And now we can ask for different kind of noises. And I'm going to put the volume rather low, otherwise it's going to be very unpleasant for you. Like if I want a white noise, I just call it white. Yeah, and you heard it with. I killed it really quick. Let's actually put it like even lower. We can have pink noise, and we have a generator for brownian noise. And on top of those noises, we can also generate waveforms. So we can generate like a sine. So all waveforms are generated as a A4 node, so the 440 Hertz frequency. So this is an A4 sine. We can generate triangle, sawtooth, yeah, not the most pleasant one, and square. And if you want to play like different notes, all you have to do is change the pitch. So, for example, the pitch for C4 is 261.6 Hertz. So you could do the division, divide 261 by 440 and put the pitch here, but you can also opt to do it for yourself. You can say divide my destination pitch, which is 261.6, by the initial one, the frequency, and we get a C4. And obviously, you can like become a bit more like advanced if you want like to have notes. You can say you can add like audio frequency here, for example, like to 61.6. Let's say A5 is 880, and here you could make a template like with notes, and notes it's actually a template. So let's say that we want a sine, which is usually a bit more pleasant, and the pitch we're going to oops, we're going to say we want a command that's going to push getting the notes of our section. We're going to retrieve inside the notes what is the frequency, and then we're going to divide that frequency by 440. And by doing this, now I can play like sound. I say sound in a rhythm note, and now I say my note is going to be like C4. We have a C4. And if we were to say like I want an A5, there we go. That's more readable, and by just using like a bit of config foo. Speaking of which, config. My last topic for config is recently we're adding more options to help you find your typos when you write things. So like,
First,
yes, questions.
while you're on the topic of the music and things, do you think you could combine several sounds to create a chord?
Yes, you would have to have multiple objects though. You cannot do it in one.
Do you think maybe you could show an example?
Sure. Okay. Um, Unscripted. Let's go. Chord. Child list. I want my C4 and my A5 at the same time, right? And I'm going to define C4 being a note. And let's see if we can be even smarter than that. Let's say that the note is going to be our name. And let's see if it works. And A5 is a note. So we don't even need to say this. We have C4 and A5, and we have a chord that's going to spawn both C4 and E5 at the same time. And so instead of creating sound, let's create chord and see if we have both. It's not the best chord, but it worked.
That's awesome. Is there
There you
a
go.
limit on the amount of channels audio-wise?
No, it's going to be your processing power. I'm pretty sure they're quite cheap, but let's also first thing first, because it's really not a pleasant noise. Let's put volume of 0.01 so we don't hear them, just so that we can look at the profiler. Okay, so looking at the profiler, everything is going to happen on the processing sound here. So for the duration of 2, it doesn't even register above microseconds. So you know what? That is going to be a bit silly here. Let's see, we have, oops, an entire orchestra playing a bunch of them. And let's see if it registers. Okay, okay. No. So I'm pretty sure that whatever target you're going to use, even like a 15-year-old computer, it's very unlikely you're going to hit any limitation in this kind of things. Any other question on the noise and wave generation?
Not yet that I can see, but this has a lot of potential for musicians out there who want to use orcs.
Oh yeah, but I mean that this is like really. I don't know if you can make like an actual like an instrumentation thing like this. It just sometimes you might want to have like a placeholder sound or something like this, and that's definitely useful. The noise one is probably more useful, but who knows? I mean, it's there, so feel free to use it. Last one. Let's go into debug because it's something that only happens in debug. If you make a typo, so before, like, let's say I put childless with an uppercase D, and we create it like this, it says, oh, childless was found instead of keys childless with a lowercase d. Is it a typo? This used to be there already in Orcs. We were doing like case comparison to make sure that you didn't make a case typo. But let's say that your typo was something else, like you forgot the D. Orcs was not able to tell you that it was a mistake before, but that's not the case anymore. Now you can see, oh, childless is very close to childless. Probably that's what you meant. And it can handle like deletion, it can handle addition, like child list. So you can see it's found with typo, and it can handle like inversion. There we go. Slid list close to child list is a typo. And you can have multiple, you can have up to 2 in words that are more than 5 letters. So let's say that I have an inversion here and I have like an omission here. It will still be able to tell that it should probably have been childless. And if you make a third one, though, that's why it's not going to bother. 3 typos is the maximum where I put. Otherwise, you're going to have a lot of false positives. So I limit it to 2. And that works for any config values. Like if I have this, that equals 12, and let's say that I put it with an uppercase H, and in config, in the console here, I say get this, that. You see that here it says, oh, that was found instead of that. Is it a typo? And obviously, if I put uppercase H and that's what I wanted, I get the value. Okay, that's all there is for typo detection. Any question in this one? Okay, so we're already a bit over 1 hour. I have about a 15-minute topic left if you're interested. It's how to hot swap resource bundles. I know that I had this request for this live. We've seen in the past how to hot swap resources. Like, for example, if you have like a set of resources that are high resolution and low resolution, how to hot swap them and on the fly and orcs update all your textures, sound, and whatever resources you're using. But you can also do the same with bundles. So if you're okay, I can go through that.
I don't hear any complaints.
Let's go over it. Let's remove everything here. Up. Let's keep our scene. Oh yeah, for the people who are not familiar with orcs, all the code in here, there's basically not much. That's the entire code of the application. All we were doing here was to create, to initialize the mode, which is the extension we were using for ping um, module, and we were creating an object called sine, and that was the only thing we were doing. Everything else happened in config. Like our object even was just a stub, not doing anything. So going back to here, we're going to create a little guy called hero, and we're going to reuse the same data I used during the resource demo, which I put here. We have high res and low res texture. Let's put them in our live data and let's put in texture. And what it is that iRes are just like an animation for idle animation for our hero, and it's basically him bouncing like this. And this is like the regular iRes one. And if we look at the low res one, it just means like resampling it at a much lower resolution, and you can see it's very chunky. So it's just to illustrate our feature here. Nothing fancy. So now that we have the data, here we can create our hero. Let's say we have a hero. It has an animation set. Let's say it's ourselves. He has a start animation, which is called idle. And that's the only animation we're going to use. Because it's not part of a sprite sheet, it's going to be separate frames, and we're going to have to get the name of those. I did not rename them, so they are named a bit silly. Yes, and when I say a bit silly, there we go. So, first thing, we have to make sure that we are going to look into the right place. So let's remove this bundle. We're not going to do this there. So we don't care about sound right now. So we only care about our texture. And we have data, texture, height, so start animation, key duration, I believe it should look okay, 30 frames per second. And our idle is just going to loop, and it's based on this with 4 digits, and it has a PNG extension, and we say that there are 4 digits. So I have the start animation, the key duration, the description of the animation that's going to loop, and the digits. So if I create, let's center it, so like it's nicely like pivot center. So if I were to create the hero, if I didn't mess up, I did mess up. Why did I mess up? Idle was another, that's fine. Failed to create animation, couldn't create any frame. Oh yes, because that's not where it is. It's in hero, idle. There we go. There we go. Our little guy is animated and it's there. And if you remember to do like the swapping, what we do is basically we remove the current storage. So we say that resources, you remove the storage for texture. You can remove all of them. Let's do this. Remove all the storage. And we're going to now add the storage for texture. We're going to add a new one, which is data texture low res. And we ask to sync our resources. And as soon as it's going to sync, all the resources that are found in the new places are going to be automatically reloaded. And you can see that now we're back to low res, guy. So everything has been updated in memory, and everything is pitchy. And if we were doing the same thing, but this time going back to high res and syncing again, we're back to high resolution. And your code doesn't have to know about this. Ox handles everything, all the syncing of the resources. Now, let's do it with bundles. So the first thing is that we need to create our bundle, right? We need a bundle for the high resolution and a bundle for low resolution. So the easiest way to do this is create separate config files. So let's go use Sublime Text for this because I'm more used to this. Let's go to data, config. Okay, we have, where is my window? It's the wrong one. Sorry. There we go. So line 1, we're going to create a new one that's going to call it iRes.ini. And iRes.ini, we're going to say the resource for the texture are coming from data texture, texture iRes. And for the bundle, we're going to say, I don't want to bundle the sound, the config, or things like this. So we're going to actually exclude everything, even texture. We're going to ignore, like, for example, the texture of the logo that was at the root in data texture. We're going to ignore it. We're going to ignore texture, the config, the sound, and anything else. And we're just going to include what is in here. And because we do this, when we're going to ask for the bundling, so I should probably compile the bundle version. It's just a release, but with output. So when I'm going to run it, and let's go in the right place on the command. We're going to go. Oops. We're going to go to bin, and here we have the live 11. We call it -b, and we're going to use the high res. Oh, I put it in config. I put it. Yes, I put it in config. You know what? Let's put it in bin. It's going to be much easier for the future and less chance for me to type incorrect path. Oh, actually, no. Okay, so it's here. So the config is in data config high-res.ini, and the bundle name is going to, let's call it high-res.obr. And that's it. And he found all the, so he excluded texture config sound, but it does include the one from iRes. So you can see that the rule iRes included all our textures from the hero. And in 0.09 seconds, it did the bundling, and we have a 792 kilobytes bundle in the end. And this one is a high-res one. Well, we can do the same kind of thing for the low-res one. So, and low-res INI, and here we're just going to swap. You know what? Actually, yeah, I could just say add resource texture. There we go. This way, I don't have to type it twice. Inheriting from resource texture. There, easy. And now if I were to ask to do a bundle called low-res, there we go. And it's a much smaller one, 100 kilobytes, but everything is coming from the low-res one with this rule. We have two bundles. Now, if we look at it, we have the high-res one, which is 800 kilobytes, and the low-res one, which is 100 kilobytes. So the only thing we need to do now is to tell Orcs to use them. So in the live.ini, let's go back in here. Here, instead of this, we can say now, I want also to use the bundle. By default, let's use the high-res, high-res.obr. And if we start it, I messed up something. Oh, I started the bundle one. That's not what I wanted to do. My bad. It means that I bundled everything in memory. No, I've created a new OBR that we're going to do, which is called live11.obr, because I run not the release, but the bundle one. So let's actually run the debug. This way we're not going to make a mistake. And you can see that the guy is here. And let's verify that it's coming from bundle. So resource locates the storage texture, and I have to copy the name because I don't remember it by heart. So data, texture, iRes, hero, either. Let's take the first one. Copy. So I want hero, either, and there are spaces. So of course there are spaces. Okay, and it comes from the bundle iRes. Fine. So now to a swap, it's same as before. I can say resource, remove storage, and this one, let's be specific. We're going to remove specifically the iRes one. And it says, okay, we remove the storage. Let's add a new one, which is going to be the low one for texture. So bundle low res OBR. And let's sync. And ta-da! I swapped resources through bundles. Now it's loading from the second bundle. If we are to locate it, it comes from the low res.obr file. And that's it. Any question on this one? And same thing, if I were to remove storage, add it again with high-res, and sync, we're back to high-res, and if we locate it, we're back to the high-res one. Any questions?
We may be getting one. Just hold on a second.
No worries. And I'm done. That was the last feature I wanted to showcase today.
Ah, they were just saying very cool, and thank you for the stream.
My pleasure. Well, thank you all for joining us and being with us. And I wish you all a good day. Unless you have questions, of course. I mean, sorry, maybe I was too fast. All good. Have a good one, everyone.
Take care. Goodbye.